Hey guys, so what I'm going to do here with Google Drawing is I'm going to demonstrate how to draw Bohr models. We're going to continue to use APE MAN to identify the amount of subatomic particles in each element. I'm going to still use lithium. So the first thing I want to do is APE MAN. And what I'm going to do here in this text box is identify the atomic number, which is 3. So what that means is the number of protons is also 3, and I also have 3 electrons. Okay, my mass number is going to be 7. This says 6.94, but I'm going to round up. 7 minus my atomic number, which is 3, is going to give me 4 neutrons. Okay, so let me review real quick. A is your atomic number, which is here. I have 3 protons, 3 electrons. My mass number is 7. I rounded the atomic mass up. 7 minus my atomic number of 3 gives me 4 neutrons. Okay? Before I get to the 1, 2, 3 part, I'm going to start drawing my atom. So what we're going to be drawing is a Bohr diagram or a Bohr model. So for my Bohr model, my first rule is going to be start with your nucleus. Okay? And inside the nucleus are your protons and your neutrons. And inside my nucleus, I'm going to have 3 protons. There. Red dots are my protons, and they are positive. I'm going to have 4 neutrons. So protons and neutrons are the same size. All right, our second rule is to identify the number of energy levels that we need. So the way that I do this is I identify what period this element is. Okay, energy levels are where our electrons live. Lithium is in, if we look at our periodic table, group 1, period 2. Because it's in period 2, that tells us it has 2 energy levels. So I'm going to draw my energy levels. There's 1. Okay, there are my 2 energy levels. Now I'm going to draw my electrons. Electrons are much smaller than protons and neutrons. Okay, now where do I put my electrons? How do I know? This brings us to our third rule. We call it the 288 rule. Okay? And what that is we're going to use this 1, 2, 3 portion for that. So the 288 rule tells us that the first energy level, this first ring, can only have a maximum of 2 electrons. It can have less, but it cannot have more. The second energy level cannot have more than 8 electrons. It can have less, but it can never have more. And the same rule is for the third energy level. So lithium has a total of 3 electrons. It is in period 2, so it only has 2 energy levels. Because I know it only has 2 energy levels, there's not a number here. There's no electrons in the third energy level because it doesn't exist. The first energy level can only have 2, so that means I only have 1 in the second, giving me a total of 3. There are my 3 electrons. I'm going to move them. 1 in my first energy level. 2. My first energy level is now full. And then my 1 in my third energy level. And that is what a Bohr model for lithium looks like. It illustrates my nucleus with the correct number of protons, 1, 2, 3, and the correct number of neutrons, 1, 2, 3, 4. It illustrates the correct number of energy levels. Lithium is in period 2 on the periodic table, which is the horizontal row. Therefore, it has 2 energy levels, 1, 2, for a total of 3 electrons, 1, 2, 3. And then we followed our 288 rule. Maximum of 2 in the first energy level, and we only have 1 extra in our second energy level. Now I'm going to illustrate a larger atom so that you can see the full 288 rule. Okay? All right, so let's do APE MAN for sodium. Sodium has 11 atomic number of 11, therefore it has 11 protons and 11 electrons. It has a mass number of 23 and an atomic number of 11, therefore the number of neutrons is 12. Okay? Sodium is in group 1, period 3, so it's going to have all 3 energy levels. Its first energy level can't have more than 2. Its second energy level can't have more than 8, meaning there is 1 electron in the third energy level. If you add this up, you get 11. 8 plus 2 plus 1 is 11, which is the total number of electrons. So I'm going to draw. First, you start with your nucleus. Okay. I'm going to make a text box. I'm just going to write in how many protons and neutrons there are in the nucleus. Okay, so you have 11 protons and 12 neutrons. Protons are positive, neutrons are neutral. We're going to have 3 energy levels. And we're going to have 11 electrons. Okay, so we have our 11 electrons. Now I'm going to place them. So following our 288 rule, we did our electron configuration right here. I know that only 2 go in my first energy level. So 1, 2. And then I know that I'm going to put 8 in my second energy level. Two, 3, 4, 5, 6, 7, 8. And then in my last energy level, I only have the 1. All right, and so that is what my Bohr diagram for sodium looks like. And this really simplifies things for you so that you know how many electrons to put in each energy level, rather than just counting and illustrating that as you go. It also allows you to double check yourself. So you need to have 11 total. Sometimes when you're just drawing a lot of dots, you can have extra or not have enough. This really allows you to double check yourself. So 2 in my first energy level, 1, 2, 8 in my second, 2, 4, 6, 8, and 1 in my third, giving me a total of 11 electrons.